Dinosaurs, the mighty rulers of Earth for more than 160 million years, dominated landscapes ranging from dense forests to vast plains, from tropical wetlands to arid deserts. Their reign spanned multiple eras, from the Triassic through the Jurassic and into the Cretaceous, creating a world of staggering biodiversity. From the towering Brachiosaurus with its long neck grazing treetops, to the swift and cunning Velociraptor hunting in packs, and the ferocious Tyrannosaurus rex asserting dominance over its territory, dinosaurs filled every ecological niche imaginable. Their evolutionary success was staggering, a testament to adaptation, innovation, and resilience across geologic time. For tens of millions of years, they evolved, diversified, and survived climate shifts, volcanic eruptions, and changing ecosystems. Yet, despite their dominance, they were not invincible. Life on Earth is defined by change, and the forces that would end the age of dinosaurs were vast, indiscriminate, and relentless. The story of their extinction is a combination of catastrophe, vulnerability, and the delicate balance of ecosystems disrupted by sudden external forces. By the late Cretaceous, around 66 million years ago, dinosaurs were thriving, but also facing growing pressures. Climate fluctuations, volcanic activity, and changing sea levels altered habitats. Some regions experienced extensive volcanic eruptions, particularly the Deccan Traps in present-day India, spewing massive amounts of lava, ash, and gases into the atmosphere. These eruptions released sulfur dioxide and carbon dioxide, triggering acid rain, atmospheric cooling, and greenhouse warming, dramatically altering climates over centuries. Plant life suffered, particularly species forming the basis of herbivorous dinosaur diets, which in turn impacted the larger food chain. Though dinosaurs were resilient, prolonged environmental stress can erode even the most dominant lineages. The decisive blow likely came from the sudden impact of an enormous asteroid, a cataclysmic event that transformed the world overnight. The Chicxulub impactor, estimated to be over 10 kilometers in diameter, struck the Yucatan Peninsula in what is now Mexico. The energy released was equivalent to billions of nuclear bombs, creating a massive crater, triggering earthquakes, tsunamis, and widespread wildfires. Dust, ash, and debris were flung into the stratosphere, blocking sunlight for months or even years, a phenomenon known as an impact winter. Without sunlight, photosynthesis slowed dramatically, killing off plants that formed the base of the food chain. Herbivorous dinosaurs starved first, followed by the carnivores that depended on them. Entire ecosystems collapsed under the cascading effects of starvation and climate disruption. The asteroid alone may not have been sufficient to wipe out all dinosaurs if not for its timing. Species were already stressed by volcanic activity, fluctuating temperatures, and habitat changes. Ocean acidification resulting from volcanic carbon dioxide and sulfur emissions disrupted marine ecosystems. Tiny organisms forming the base of the oceanic food web perished, causing ripple effects across marine reptiles and fish-dependent species. Combined with the impact, these cumulative stresses proved catastrophic. Dinosaurs, despite their size, strength, and adaptability, were ultimately unable to survive the sudden environmental upheaval. The extinction was uneven. Smaller species and those capable of burrowing or exploiting diverse diets had a higher chance of survival, while large-bodied specialists suffered most. Among the survivors were small, adaptable creatures, many of which were early mammals, birds, and other small reptiles. These survivors were often small in size, able to exploit niches overlooked by dinosaurs, and capable of rapid reproduction. The end Cretaceous extinction, also known as the KPG boundary event, reshaped life on Earth completely. The removal of dinosaurs as apex terrestrial predators created ecological opportunities. Vast territories, abundant food sources, and open ecological niches became available to mammals and other surviving lineages. The Earth, once dominated by dinosaurs, now faced a new era, one in which mammals would gradually diversify and evolve into forms that would eventually include humans. The rise of mammals was slow, but transformative. Initially, mammals were small, nocturnal, and relatively inconspicuous, avoiding predation by living in burrows and feeding on insects, seeds, and small plants. Their evolutionary potential, however, was immense. Freed from dinosaurian dominance, mammals began to diversify in size, shape, and behavior. Within a few million years, the planet saw the emergence of larger herbivores, specialized predators, and increasingly complex social structures. This diversification laid the groundwork for the eventual rise of primates, the group to which humans belong. The story of humans is thus deeply connected to the fate of dinosaurs. One lineage's demise became another's opportunity. Early humans did not appear for tens of millions of years after the extinction of dinosaurs, but the Earth they inherited was shaped profoundly by that event. Forests, grasslands, and savannas expanded into spaces once dominated by massive reptilian megafauna. Rivers, lakes, and coastal ecosystems flourished with smaller, warm-blooded creatures that humans would later rely on. Evolution produced primates capable of grasping hands, forward-facing eyes, and complex social behavior, traits that would eventually enable tool use, communication, and cooperation. The extinction of dinosaurs was not simply a story of death. It was a story of ecological transformation, creating the conditions necessary for mammalian and eventually human dominance. When humans emerged, they encountered a world still recovering from these massive shifts. Ice ages, volcanic eruptions, and glacial cycles shaped the continents. Humans, like their mammalian ancestors, relied on adaptability to survive. Unlike dinosaurs whose size and specialization had limited flexibility, humans thrived through culture, tool-making, and cooperation. Early humans hunted animals, gathered plants, and developed survival strategies finely tuned to their environment. Their intelligence, communication skills, and capacity to innovate allowed them to exploit diverse habitats, from forests to tundras to coastal zones. Unlike dinosaurs, humans did not rely solely on instinct. They relied on knowledge transmitted across generations. The human takeover of Earth was gradual, but it became inevitable because of the unique combination of cognitive skills and social behavior. Small groups coordinated hunting efforts, shared food, and defended against predators. Early humans made tools from stone, bone, and wood, using them to cut, crush, and process food. They learned to control fire, providing warmth, protection, and a method to cook, which increased nutritional efficiency and reduced disease. Over tens of thousands of years, these skills accumulated, allowing humans to inhabit virtually every continent. By the time Homo sapiens migrated out of Africa, they were already equipped to face varied climates, predators, and ecological challenges. Human expansion did not occur in a vacuum. Other hominins, such as Neanderthals and Denisovans, also adapted to specific regions, displaying intelligence, tool use, and social structures. In some cases, humans interbred with these groups, sharing genetic material and enhancing survival. The replacement of other hominins, coupled with human adaptability, ultimately led to Homo sapiens becoming the dominant species. Unlike the extinction of dinosaurs, which was sudden and catastrophic, human dominance emerged gradually through competition, cooperation, and ecological understanding. Humans shaped ecosystems not by sheer size or predation, but through knowledge, innovation, and manipulation of resources. Agriculture, which appeared roughly 10,000 years ago, accelerated human dominance. By domesticating plants and animals, humans could support larger populations and reduce dependence on hunting and gathering. Settlements grew, social structures became more complex, and technology advanced rapidly. Human activity began to alter landscapes on a scale unmatched in previous epochs. Forests were cleared, rivers diverted, and animals selectively bred. While dinosaurs had shaped ecosystems through predation and grazing, humans transformed them consciously, shaping the Earth to suit their needs. The dominance of humans was not merely survival, it was engineering, cultural innovation, and environmental control. The extinction of dinosaurs and the rise of humans share an interesting paradox. Dinosaurs, despite their incredible adaptation and evolutionary longevity, were unable to survive abrupt planetary changes. Humans, on the other hand, survived by using intellect, social cooperation, and cultural flexibility. Where the dinosaurs relied on physical evolution and specialization, humans relied on innovation and foresight. Knowledge accumulated faster than genetic adaptation, allowing humans to overcome environmental obstacles that had previously ended species. This difference explains how humans, once a small and fragile primate species, could eventually claim dominion over a planet previously dominated by creatures that weighed tens of tons. Humans also impacted the planet in ways